Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at solving cubic equations. So this here is a cubic equation because this is a polynomial of degree 3. It is a cubic. So I'm going to name this polynomial fx just to make it easy to refer back to. So obviously what I want to find values I can substitute for x that make this a true statement. Now for cubic equations, they can have up to 3 solutions. So it's not easy to find them. What we do is we actually come up with one of the solutions and then use polynomial division. So if you're not given a solution to the equation to begin with, what you do is try factors of the constant term. That's due to a simplified version of the rational root theorem. Now you need to try both positive and negative factors of this constant term. So for example, let's try 2 as a solution because 2 is a factor of 6. If I substitute x for 2 into the polynomial, I get 28. So clearly 2 is not a solution to this equation. But if I try negative 2, I hit pay dirt. If I substitute x for negative 2 in here, that means that this equation is a true statement. So x equals negative 2 is one of the solutions. But as I said, there are up to 3 solutions to a cubic equation. So how do I find the others? Well, note that negative 2 is a solution to this equation is equivalent to saying negative 2 is a root of the polynomial fx. So the factor theorem tells us that fx can be divided by x plus 2. Remember, it's always the negative, the opposite of the root that you find. X plus 2 must be a factor of this polynomial here. So what I'm going to do is I'm going to divide fx by x plus 2. That will give me a quadratic and I can factorize that easily. So how do I perform polynomial division? Well, there are 2 ways I'm going to show you. First, polynomial long division and then synthetic division. So for polynomial long division, I'm finding what do I need to multiply by x plus 2 to get this polynomial here. So basically, I know I'm going to need to times a quadratic polynomial by x plus 2 to get this cubic. So all I really need to find are these coefficients. That's what polynomial long division is. It's basically a constructivist approach. I'm going to construct a polynomial that when I multiply by x plus 2 gives me this. So we're going to start by looking at the leading terms. 8x cubed divided by x gives 8x squared. I've just found this coefficient needs to be 8 if this times this equals that. So then what we're going to do is we're going to calculate the remainder. So we take our 8x squared, we multiply it by x to get 8x cubed, and then we multiply 8x squared by 2 to give us 16x squared. So to calculate the remainder, we subtract. Of course, 8x cubed minus 8x cubed is 0. 2x squared minus 16x squared is negative 14x squared. So whenever you get a remainder, divide it by the leading term, always by the leading term. So negative 14x squared divided by x gives negative 14. So we figured out this coefficient has to be negative 14. See, the thing was, if I have the 8x squared here, when it gets multiplied by the 2, I get 16x squared. So what has to happen? This has to be negative 14x. So when it's multiplied by the x, I get negative 14x squared. Because 16x squared minus 14x squared gives me 2x squared. So this had to be negative 14 so that this term was correct when I multiply this by this. So we're sort of going to follow the same process. So we're going to bring down this negative 25x. So remember, when I get a term up here, negative 14x, I multiply by both terms. So I multiply by x and then I multiply by positive 2. So remember, as I said before, when finding the remainder, you always subtract. So this minus this is just 0, but negative 25x subtract negative 28x gives us positive 3x. Whenever you get a remainder, you divide by the leading term. So 3x divided by x is 3. So I found out this has to be a 3. So why is that? Well, when I multiply this by this, when I do negative 14x by plus 2, I get negative 28x, but I wanted negative 25x. So putting a 3 here, so when I go 3 times x, I will get 3x. Negative 28x plus 3x is negative 25x. So now I've made sure that all of these three terms will be correct when I multiply this by this. So that is always the case. When you're performing polynomial long division, you'll get a polynomial up here, and it will make sure that all the terms with x's in them are correct when you multiply these two together. It won't always get the constant term right. If it doesn't, of course, that's when we have a remainder. The very last step of the polynomial long division, we're going to perform one more round of it to check the remainder of the whole thing. So I bring down the 6, so I go 3 over here times x is 3x, 3 times positive 2 is 6. The remainder of the whole thing is 0. So this final number you get is the remainder of the whole thing. You should use the remainder theorem to check that you get the same answer from polynomial long division as you do from the remainder theorem. That will tell you if you're on the right track. So for example, I knew that x plus 2 was a factor from up here. So I expected to get a remainder of 0. So now I know I'm on the right track. So I have factorized fx as x plus 2 times this polynomial at the top, 8x squared minus 14x plus 3. So now I can factorize this because I know how to factorize quadratics. This requires the AC method. So AC, 8 times 3 is 24. The two numbers that multiply to 24 and add to negative 14 are negative 2 and negative 12. So I split up the middle term accordingly. Then I factorize first two and second two terms separately. So then, of course, I take out the common factor of 4x minus 1 out the front, and 2x minus 3 goes in the other brackets. So when you factorize fully, we can just use our old friend, the null factor law. Either the first bracket equals 0, the second bracket equals 0, which would mean x is 1.5, or the third bracket equals 0, which would mean x is a quarter. So they are the three solutions. So that's all using polynomial long division. So if you get to this step, fx divided by x plus 2, instead of using polynomial long division, you can use synthetic division. Synthetic division will get us to here, get the same answer, and then we just factorize as normal. So let's now look at how we do this using synthetic division. So when we performed this division using polynomial long division, we had to write heaps of x's, and that can lead to people making mistakes. You would have also noticed that we subtracted every time we wanted to find the remainder, and for some reason, subtraction usually trips up a lot of people. So there is a method that avoids writing all of the x's and allows you to add rather than subtract, and it's called synthetic division. So to do synthetic division, we just write the coefficients of fx, the polynomial we're dividing something by, so 8, 2, negative 25, and 6. Now for synthetic division, instead of writing the opposite of the root, like plus 2, which is what we did when we were using polynomial long division, here we're going to write the root, negative 2. So we write it like this. So here we're always dividing by a monic linear factor, so the coefficient of x is 1, so I can just put this 8 straight down. So what I do is go negative 2 times 8, and that gives me negative 16. Now what you do here is you add to find the remainder. So 2 plus negative 16 is negative 14. So when I get something down here, I times by negative 2 my root. So negative 2 times negative 14 is positive 28. So to find the next coefficient, once again, we add when it's synthetic division. So negative 25 plus 28 gives us positive 3. When we get something down here, we multiply by the root. So negative 2 times 3 is negative 6. And then 6 plus negative 6, once again, we add to find the remainder. That just gives us 0. So this was coefficient of x cubed, x squared, x, and constant term. In your solution, the degree is 1 less. So this is the coefficient of x squared of x This is the constant term, and this here is the remainder of the whole thing. So as I said before, since we knew that x plus 2 was a factor, we expect to get a remainder of 0. So we found that fx, which was this polynomial up here, we knew that x plus 2 was a factor. We've just found using synthetic division, the coefficient of x squared is 8, the coefficient of x is negative 14, and the coefficient, or the constant coefficient, is 3. So this is exactly the same thing that we obtained using polynomial long division, but a lot of people find synthetic division easier. You can use either. So when you've got a cubic equation like this to solve, you need to come up with a solution. If not given one, you come up with a solution by trying positive and negative factors of the constant term. So when you've done that, you need to perform a polynomial division. Whether you use polynomial long division or synthetic division doesn't matter. The aim here is we reduce this cubic into a linear term times a quadratic, and then we can factor this quadratic using the methods we've previously learned. Our final step is then to use the null factor law to find the solutions of x. Yes, this does take a while and it is complicated, so practice, practice, practice. Thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.